Welcome to my YouTube channel Statisticians Club. I hope everyone is fine. Please subscribe the channel, also press bell icon to receive latest videos. In this video I solve two questions about hypothesis testing, in which we test about mean when data is drawn from normal distribution. Here is the statement of question. Question number 1. A random sample of size small n is equal to 25. Small n is the notation used for sample size drawn from sample. Values give sample mean, x bar represented by sample mean, which is 83. Can this sample be regarded as drawn from a normal population with population mean mu is equal to 80 and standard deviation, which is 7? So in this question we find population mean mu is equal to 80. So a random sample is drawn from normal population having specified value mu naught. Specified value mu naught is equal to 80. Mu is equal to mu naught. Mu naught is the specified value in general form, which is 80. And non-standard deviation sigma, which is 7. Formulate hypothesis h naught mu is equal to 80, which is null hypothesis, and the alternative hypothesis h1 mu naught equal to 80. Mu is equal to 80, as you know, equality sign always used in the null hypothesis, and this is we want to calculate is population mean mu is equal to 80. And its opposite is not equal to 80, which is alternative hypothesis. Level of significance did not specified in the statement, so we use 0.05. Mathematically it is represented by alpha. Alpha is equal to 0.05. So we use level of significance alpha is equal to 0.05 because this is most commonly used level of significance. Next step is test statistic. Test statistic to be used for random sample drawn from population with non-standard deviation is z is equal to x minus mu over sigma over under root n. X is sample mean, mu is population mean, sigma is standard deviation, and root n is sample size. Critical region. Because not equal to sign means two-tailed test is used. Data is on shape of distribution is such that it is on right side and as well as on left side. So for two-tailed test, two types of critical region. Here is simple one, z mod greater than or equal to z alpha by 2. This mod is absolute value. It means z has plus and negative values both. Alpha by 2 means alpha is on both sides, so we divide alpha by 2. We can also use test statistics z greater than z alpha and z less than minus z alpha for two-tailed test. But this is the simple one we use here, z mod greater than or equal to z alpha by 2. So alpha is 0.05 divided by 2, and we check its value from z table, which is 1.96. Computation. Now we calculate z from sample data. Z is equal to x bar minus mu naught over sigma over under root n. X bar is the sample mean, mu naught is the specified value about population mean, sigma is the population standard deviation, and small n is the sample size. 83 minus 80 over 7 over under root 25. After simplification we got answer z is equal to 2.14. Because this computed value is greater than the table value, so we accept the alternative hypothesis and reject our null hypothesis. Since our calculated value z is equal to 2.14 falls in critical region, so we reject our null hypothesis h naught mu is equal to 80 and accept alternative hypothesis, which is h mu naught equal to 80. And we conclude that sample mean x bar is equal to 83 cannot be regarded as drawn from population with mean mu is equal to 80 because we accept our alternative hypothesis. So we cannot assume that sample drawn from population with mean is equal to 80. Here is the figure. Because the value computed value 2.14 greater than 1.96, this is the table value, so it falls in critical region and we accept alternative hypothesis H1. If this computed value is less than 1.96, so it fall in the acceptance region and we accept our null hypothesis. But in this case it exceeds from table value, so we accept alternative hypothesis. Question number 2. Test the hypothesis that mean of normal population with known variance 70 is 31. If the sample size 13 gave x bar is equal to 34. Let the alternative hypothesis H1 mu greater than 31 and alpha level of significance is 0.10. We check with this level of significance and alternative hypothesis is given in the question. So if alternative hypothesis is greater than, so its opposite sign are less than or equal to. So this is our null hypothesis H1 mu less than or equal to 31 and H1 mu greater than 31. So less than or equal to, as you know, equality sign always appear in null hypothesis. Level of significance alpha is equal to 0.10. Test statistics. Third step, test statistics to be used for random sample drawn from population with known standard deviation is, this is the formula for test statistics when sample is drawn from normal population and with known standard deviation. Z is equal to x minus mu over sigma over under 10. Under H0 it is the standard normal variate, as you know. 4 step critical region. Because this is one tail test, greater than sign. So greater than sign represent greater and less than sign represent one tail test. So one tail test, Z greater than Z alpha, Z greater than Z 0.10, Z greater than 1.28. Compute this value from Z table and the computation. Z is equal to x bar sample mean minus mu naught specified value over sigma standard deviation over under 10. X bar is 34, which is sample mean. 31 is the specified value about mean, and variance sigma square is 70. So here we have sigma, so under 70 over under 2.25. After simplification we have the Z value 1.29. Conclusion: since our calculated value Z is equal to 1.29 falls in critical region, so we reject our null hypothesis and we accept our alternative hypothesis H1 mu less than 31, and we conclude that sample mean x is equal to 34 cannot be regarded as drawn from population with mu is equal to mu greater than or equal to 31. So we accept because this is our computed value and it is greater than 1.28. So we accept our alternative hypothesis. Thanks for watching. If you want to see videos on one tail and two tail test, level of significance, type first and type second error, then click the link in front of your screen. Thanks for watching.